Assalamualaikum. Today our group will presenting about electricity and magnetism application in transportation and automotive industry. This is our group members Ahmad Akil Haikal bin Ahmad Azrai, Rifan bin Muhammad Huzaimi, and me Muhammad Zahir bin Khamir. Okay, so for introduction, electricity and magnetism are very important in today's transportation and automotive industry. They are the main reasons electric and hybrid vehicle work. Electric motor use electric current and magnetic field to create motion, which allow vehicle to move efficiently without using gasoline. Electricity and magnetism are also used in new technologies like wireless charging, where energy is transferred to a vehicle magnetic fields instead of cables. As more vehicles become electric, this physics concept play a big role in making transportation cleaner and more efficient. Okay, next, basic electricity concept use. Firstly, electric power drive vehicles. Electricity powers motors that move cars, buses, trains, and even airplanes, making electric propulsion possible and reducing reliance on fossil fuels. Secondly, battery systems store and supply energy. Batteries store electrical energy and supply it to all vehicle systems, from the engine to light, sensor and entertainment system. Thirdly, electrical circuit control functions. Understanding voltage, current and resistance help engineers design circuit that safely control lighting, climate, infotainment and safety features. Nextly, sensors and electronics enhance safety. Modern vehicles use electrical sensors for braking, collision detection, lane keeping, and autonomous driving systems. Lastly, efficiency and sustainability. Electricity enables regenerative braking and energy efficient systems, reducing fuel consumption and lowering emission for greener transportation. Next slide is magnetism concept use. Firstly, electric motor rely on magnetism. Magnets create magnetic field that interact with electric currents to produce motion in motors, powering electric cars, trains, and e-bikes. Secondly, generators produce electricity. Magnetic fields moving through coil generate electricity in vehicle alternators and regenerative braking system. Thirdly, magnetic sensors enhance safety and control. Magnetic sensors detect wheel speed, position, and rotation, enabling ABS brakes, stability control, and precise navigation. Nextly, magnetic levitation for high-speed travel. Maglev trains use strong magnets to lift and propel trains, reducing friction and allowing ultra-fast, smooth travel. Lastly, efficient energy conversion. Magnetism helps convert electrical energy to mechanical energy and vice versa, making vehicles more efficient and eco-friendly. For historical development, the study of electromagnetism began in 1820, when Hans Christian Ørsted discovered that an electric current can create a magnetic field, showing for the first time that electricity and magnetism are connected. Nextly, for this discovery was later expanded by Michael Faraday, who introduced the principle of electromagnetic induction, explaining how a changing magnetic field can generate an electric current. Other than that, building on these principles, maglev train technology was first tested in the 1960s in countries such as Germany and Japan, where magnetic levitation was explored as a method of high-speed transportation. Later, in 1997, the release of the Toyota Prius marked the first successful mass-market hybrid car, combining an internal combustion engine with an electric motor to improve fuel efficiency and reduce emissions.
Next, I'm going to be talking about the benefits of EV. The first one is environmentally friendly. EVs produce zero tailpipe emission, reduce air pollution and greenhouse gas emission. Next, it supports sustainable transportation. It also has high energy efficiency because electric motors are more effective than combustion engines. It means that less energy lost as heat. Next is also efficient conversion of electrical energy to mechanical energy. Next, it has lower operating costs, which is electricity is cheaper than fossil fuels. Fewer moving parts means lower maintenance costs. And next, no oil change required. And last but not least, it is so quiet and smooth operation. It means that electric motors operate silently, reduce noise pollution in urban areas, smooth acceleration due to instant torque. Okay, now I'm going to talking about the challenge of electric vehicles. The first one is charging infrastructure. Insufficient public charging station in some regions and also requires significant investment. Next is charging time. Charging takes a lot compared to refueling petrol or diesel. And next is fast chargers are not always available. After that, it limits your driving range. It means that battery capacity limits travel distance and range anxiety among users. And last but not least, battery cost and lifespan. Batteries are expensive to replace and also the performance degrades over time. And now I'm going to explaining about the wireless EV charging, which is inductive charging. The first one is you have to know the basic principle, which is based on electromagnetic induction. Power is transferred wirelessly using alternating magnetic fields. How it works? How it works is a transmitter coil in the charging pad produce an alternating magnetic field, and also there's a receiver coil in the vehicle induces an electric current, and then the induced current charges the battery. After that, there's advantages of wireless charging, and there is no physical cables, which means convenient and safe. And also it reduces wear and tear. And then the wireless EV works in rain or harsh weather condition. And last but not least, challenge of wireless charging, and that is it has a lower efficiency compared to wired charging. It requires precise alignment of coils and also higher installation costs. Next, I'm going to talking about the hybrid vehicles. Hybrid vehicles use both an internal combustion engine and electric motor. Electrical energy and fuel energy work together to improve efficiency. The electromagnetic induction in hybrid vehicles, based on Faraday's law, it is used when the electric motor functions as a generator, converts mechanical energy back into the electrical energy. About its fuel efficiency, electric motor assists the engine during acceleration. It reduces fuel consumption compared to conventional vehicles. And next, electric motor and magnetism in the hybrid vehicles. The electric motor operates using magnetic fields on electric currents, and then when the current flows through motor coils, a magnetic field is produced, causing a rotation. And last but not least, it then converts electrical energy into mechanical motion. And about its battery energy storage, hybrid vehicles use high voltage batteries to store electrical energy, and it supplies power to the electric motor during low speed driving. And last but not least, I'm talking about the maglev train. The basic concept is that maglev train float above the track instead of using wheels. They use magnetic force to achieve levitation and movement. The magnetic levitation is a powerful electromagnetic, then creates a magnetic field, and the magnetic repulsion or attraction lifts the train off the track and eliminates friction between train and rail. About its electromagnetic suspension, they use attractive magnetic force. The electric magnets on a train pull it upward toward the guideway, and then the sensors and control systems keep the train stable. Last but not least, it is so high speed and very efficient because there's no wheel, means no rail contact, means very low friction, and then they allow extremely high speed, over 500 km per hour, and the energy is used mainly for levitation and propulsion.
Assalamualaikum. Next, I will be explaining about the electromagnetic braking.
And first of all, what is electromagnetic braking? Now, it is a non-contact braking system that usually applies the principles of electromagnetism. Usually uses magnetic fields to slow motion, and it also has eddy currents to oppose the movement of that vehicle. And it converts kinetic energy into heat or even electricity. Now, the benefits of electromagnetic braking is that it reduces damages, increases reliability, and offers a more smoother operation. And it is usually used in, for example, electric vehicles, electric trains, high-speed transport systems, and many more that uses electromagnetic braking. And here are the potential future developments. And for the first one, we have advanced battery technology, where it is a development of solid-state batteries, where it provides higher energy density and faster charging, and thus also providing safer and longer battery lifespan. For the second one, we have wireless charging roads, where it is a road embedded with electromagnetic coils, and vehicles can be charged while driving using the electromagnetic induction on the wireless charging roads, and thus it reduces the need for frequent charging stops. For the third one, we have fully electric public transportation, where electric buses, trains, and trams replace diesel systems and will be powered by efficient electric motors and regenerative braking. And thus, it reduces air pollution in urban areas. For the fourth one, we have superconducting maglev trains, where you use superconductors to produce extremely strong magnetic fields, and it has high speeds with lower energy loss. Therefore, it provides even smoother and quieter travel. For the fifth one, we have autonomous electric vehicles, where it is a combination of EV technology and artificial intelligence, where it provides smart energy management using sensors and electronics. And with this development, it can support smart cities and traffic efficiency. So, in conclusion, we can say that electricity and magnetism are essential in modern transportation because it offers a wide range of real-world applications, and its benefits outweigh the challenges. Thus, we can say that the future transportation depends on electromagnetism. So here are the given references for our video presentation, and that is all from us. Thank you very much for listening.